This video will demonstrate some of the fault analysis which is included in the full release of eSimulate. The circuit we have here is a cut down and simplistic version of an electrical system from a car, and we can see here that we have a 12-volt battery powering some side lights which are represented in this system by a resistor. The first thing I would like to do is to induce a fault into this circuit, and I'm going to do this by placing a short to ground component . What happens here is when the short to ground is placed in line with a fibre, the fibre is split into two, and initially the lengths are halved, and we can see this shown in the panel here, with wire 63 being on the left hand side of the short and wire 64 being on the right hand side, and each of these at present are set to half of a metre. This slide control allows me to modify the lengths of each of those fibres so we can move the short from left to right along the fibres. And we can apply the change in length, and this is reflected to each of the fibres. If we run this simulation, we can see what the effects of having the short to ground in place, and we can compare this to the original good values when we remove the short to ground. As we can see from the simulation results here, the current being drawn from the battery is just over 11.2 amps, while the current being drawn from the side light resistor is only 111 milliamps. If we remove the short to ground, we can see that the fibre length has been returned to its original value, and if we rerun the simulation, we can see that the current being drawn from the battery now is only 120 milliamps, and this matches the current being drawn across the resistor. If we place the short to ground back into the circuit, we can modify its ground impedance value, and this allows me to modify how much resistance between the earthing short and the fibres there is. If we set this to 0, this will represent a straight short to ground, and the current being drawn will be much higher. As we can see here, it's now 165 amps, and there is no current being drawn across the resistor, versus 11 amps across the battery and 111 milliamps through the resistor when we have a ground impedance of 1 ohm. This concludes the fault detection and analysis functionality which is included in the full release of eSimulate.